ladies and gentlemen. I'm going to show you 4 different ways to start a small motor. Motor's a 300 watt capacitor start motor, but the principle is pretty much the same throughout all of the single phase motors, whether it be 115 volt or 230 volts. The controls can be set up the same way. It just depends on how you wire them up. The first one here is a latching it's not momentary, it's actually latching. So I'm running it through a relay to start the motor. It will continue to run as long as voltage is put to it. You push it again and it releases the latch. The second one here, this is very common, what you might see. This is a relay that might be in a air conditioning unit, but it's suitable for starting motors up to about 40 amps. So it's a real common, real sturdy relay, definite purpose. See them all the time. I've got it hooked up in such an arrangement that I'm using the relay itself to latch the power, and when we start it up, it continues to run until we hit the stop button. This circuit right there is very, very safe in case there is a power outage. The machine or the motor will not start up until you're telling it to do so. This right here is an ice cube relay. They've kind of fallen out of favor, but they are still present in a lot of equipment. This one is a 3-pole arrangement. You don't really need the third pole in this particular one because it is a single phase power, but it does help to have the capability in case one of the poles should go bad. You could switch legs and it'll operate that way. But anyways, I have this one on a very simple momentary system as well. This is a normally open start switch. Pulls in the relay and starts it up. It'll continue to run until you hit the stop button. And then the stop also ensures that in case of power outage that motor will not start up unless there is input from the operator. The last one that we have here is a good old toggle switch. Everybody knows what a toggle switch is. They're useful for maintaining contact in a circuit. You won't need any of the fancy wiring and all that good stuff to do it. Bad problem with that one though is if the power goes out and comes on hours later or whatever, whatever's supposed to be hooked up to that will continue to run. Now this right here is a SSR, a solid state relay. They're actually quite versatile to use and stuff. In this configuration, I do not have a heat sink underneath it. We are only pulling 2.5 amps out of this thing, and this is technically a 50 amp SSR. If I was going to put it into operation, I would put a heat sink underneath it, but for this low of amperage, it's not necessary. But I'll give you a little demonstration how this works on the toggle switch. And maintain contact so it'll continue to run until you turn off the toggle switch. Now obviously all of these circuits are quite simple. There's a little bit of wiring magic, not really magic. It's a couple of loops that you have to make in order for the power to be maintained, but there is no real magic to it. There is easy ways of doing it, and if you guys are interested, I'll show you how to do that. This is mainly a demonstration of different ways of starting a motor. Now obviously there would be fuses and motor overloads. For large loads and motors, for this particular size of motor, the manufacturer of the saw that came out of didn't see fit to put any safety devices in between the start button and the motor. So basically the start switch was a toggle switch like that could carry 15 amps. I never saw anywhere near 15 amps, but that they felt it was safe enough. The current draw was low enough. So I followed suit and basically made this little video explaining some of this. We can get down to each circuit. These are two different types of latching circuits here, so maybe I'll make a second video explaining each one. But for right now, this is just a preview as to what we're getting into. Thanks